The percentage of increase and decrease is another application for percentages. Of course, if we're dealing with percentages, we're also dealing with fractions and decimals. There's a ratio of the amount of the either increase or decrease from the original amount. So this formula is a little bit different than the one that we were doing before. Let's take a look at some examples and I think you'll understand. If you have a coat that was marked at $150, but now you can buy it at $120, obviously there's been a change in this price. You're going to need to think about whether the price went up or whether it went down. In this case, we have the price coming down. So this would be a percentage of decrease. It's a ratio. We have the original price of the item, which was $150. That's our denominator. Now we're going to need to know the amount of the decrease, which is done by taking the original amount and subtracting whatever you have, whatever the price is at this point. So we can, if we subtract these numbers, we're going to get 30. So there was a $30 drop in this product. This fraction could be reduced to lower terms, so the numbers would be easier to work with, or you could jump right in and do 30 divided by 150. So this is a choice to do it this way. You're going to eventually get a percentage out of this as we go through the division. Or we can reduce to lowest terms. Divisibility rules say that if you divide by 10, if the numbers are ending both in a 0, so we have already reduced this to 3/15. And then we can further reduce this by 3, 1/5. Now our division problem looks like this. 5 divides into 1. I don't know about you, but I pick the latter. We're going to add a decimal point so we can continue on with our division. 5 divides into 10 2 times, and it's even. So this fraction is equal to 2/10, and if we carried that to a percentage, we would go 2 places over to 20%. So our coat has a 20% decrease.